This time I will discuss a cable with segmental load or dispersed load. That means a cable similar to a signal, traffic signal. When you drive, sometimes you saw that traffic signals are traffic lights or signal. It is hanged using a cable. So that time the cable looks similar to this. It's not exact. I just drew one with like whatever I thought. I just drew one. You can see that the support here. There is a light here. Its weight is 2 kg. There's another light here. We do not know the load, but the shape is like this. So this is 10 feet. This one is 10 feet. This cable is 20 feet. And the slope here we measured roughly is 3 by 4. This portion 8 feet, 9 feet, 15 feet. I just wrote whatever it came to my mind. So if this is a case, how to solve this cable? Now again, uh, there might be so many different configuration, but concept is same. And here the concept is that cable can take only tension. That's number one. Cable can take only tension, it cannot take any compression. So, and that's number one. Number two, you can take any joint or you can take any section, say this section, say this section, say this section, any section. So take any joint or any section and apply, or even you can take the entire cable, no problem, and apply the equilibrium equation, summation of moment, summation of force in x direction, summation of force in y direction. So using this combination, you can solve this cable. Nothing is scary, just straightforward. Only thing is to think you have to start from the easiest point. So you start at a point, at a joint or at a section or the entire where you will get some result at the beginning that will help you. If we start somewhere that has several unknown, that will be difficult for you to solve it. So you have to find the easiest. Oh, something else. What is the question typically for cable? Common question is what is the force in defined segment? So force in defined segments are not equal. Force in this cable and in this cable may not be equal. Mostly will not be equal. If force mostly and something else, the slope. We always do not know the slope of the cable. So these are the typical two questions. Sometimes if I do not know the length of the cable, they will give you the slope and they will ask you what is the length. That is a trigonometric type problem. So main concept is what is the load in the cables, what is the slope in the cable, and sometimes we ask what is the length of the cable if slope is known, or if the length is known, what is the slope. So that are something. And now no need to memorize anything, even I do not memorize anything. So what I will do, I will first see where can I start, that will give me an answer. So if I see something here, I know the length, I do not know the slope. I know 15, but I do not know the height here. So something is unknown. So if I take this cable, my cable force is unknown, slope is unknown. So difficult this portion. If I take this portion, I know this, I know that, but I do not know the vertical. We can find it using the Pythagoras rule. But yes, at the beginning I will not try to find. I will try to find the easiest cable. So if I come here in this cable, I know the slope, I know the length, I do not know the force. So it looks like that this cable is the easiest here. So I can consider this joint or some segment. Now if I take this joint, this cable force unknown, this cable force unknown, the slope here will be known because this will be Pythagoras, right angle, this will be a right angle, a triangle. Okay, so which one to apply first? So we can apply anything. So what I will do, if I take this joint, this is unknown, two unknown. So let us find one first. What about force in this cable? So if I draw the free body diagram, the force in this cable, say this as, okay, give a name, T, A, B, C, D. So this force will be TAB. Now you can see that if I take moment here, oh, it is the same elevation. If I take moment here, only one unknown. So we can easily solve that. Um, but yes, we can easily solve it, this force. Okay, what to do? So okay, I'll take a different color. Summation of moment at d equals 0, say clock. Oh, something else also. If I take moment here to find this force, do I not need P? Yes, I need P. Do I know it? No. So I cannot apply that. So my concept was wrong. This is the way to solve any stress. At the beginning, you do not know. You have to apply first and see it. So although I started using this, it didn't work. So I will not use this anymore. Okay, then try something else. Okay, then I would say start with joint B. If I start with joint B, my B is this force is 2, and another cable that is like this, and I know the slope 3, 4. So this force is TAB, TAB, and what else? So this force will be TBC. What is the slope here? This portion is giving 9, my hypotenuse is giving 10. I can find this side using Pythagoras rule. That means 9 square plus x square equals 10 square. Then what is my x? X is 4.358, 4.36. So we got x equals, this one is 4.36. Okay, so we got the slope here, one unknown, two unknown. So now we can solve this two force law. So if there are two unknown, we can solve it because we know summation of fx is 0, summation of fy is 0. Okay, so if I apply say summation of fx, summation of fx is 0, then TAB, okay, assume a sign, say this way is positive, that way I am assuming positive, so this force is that way, so it is negative. Now what is the component of this force along horizontal direction? The rule is divided, what is hypotenuse here? If it is 4, if it is 3, this will be 3 square plus 4 square equals 5. So this is 5. So divided by hypotenuse times the corresponding side. I am taking the horizontal, so my side is 4. So 4. So this side negative, other force is TBC that way. So TBC, what is that component? Divided by hypotenuse times the corresponding side is 9. No other force in x direction, so I got that is 0. Okay, then I will solve, say, is it negative? Because this is going that way. I assume that way is positive, so it will be positive. Now if I solve this, I will get what I will get. I will get here 0.8 TAB plus 9 over 10. 9 over 10, we know that it is 0.9 TBC equals 0. Then if I solve even more, I will get TAB equals 0.9 divided by 0.8, 1.125. So 1.125 TBC. So we got a relationship between TAB and TBC. Then what we will do? We know another equation, summation of Fy. So if I apply summation of Fy is 0, say upside is positive, that way positive, then TAB, what is the component of this force and this way, divided by hypotenuse times the corresponding side. My side now it is 3 upward, positive. Next force is BC. BC is going downward, so negative. So TBC divided by hypotenuse times my corresponding side 4.36. Now my side is this because I want vertical direction. Other force is 2 minus 2 keep is 0. I already know the value of TAB in previous steps, so I can write here 1.125, then 3 over 5 TBC minus I'll get another value here, that is 0.436 TBC equal to, okay, if I solve it, this portion will be 1.125 times 3 divided by 5 minus 0.436, yes, so I got 0.239 TBC equals to, if my calculation is right, then I'm getting TBC is 8.37 keep. So I got the value of TBC. Now sometimes if there are two unknown, apply summation of fx, get, or fy whatever, get one relationship, then apply other, get another relationship, use these two, find one. If my calculation is right, hopefully it is right, because, because maybe right, maybe wrong, it should not be wrong. Okay, let me check one more time. It should be right, yes. So, and if it is not right, you know what to do actually. Okay, then once we get TBC, we can find TAB now. How? We can insert this value here, then we'll get TAB. So TAB will be 1.125 times 8.37 keep. I got 9.4 say. Okay, so we got two forces, TAB and TBC. TAB and TBC. So two forces are done. Now we can use this joint. And if we use this joint, we can find our force P. Again, something else to tell, that there is not only one way to solve it. If you think about, even if I now think about it, I can use other method. How? Okay, I should not confuse. But if I take some moment here, cut here, I could find, no, that will be difficult. I'm using the right approach, easiest approach. So then I'll go to joint C. If I go to joint C, so this is this way. Now I know this force BC. BC is 8.37. My slope here is 9. This is 10. This portion is 4.36. And I have a force here, that is P. This force TCD. What is the slope? This is given 15. This is given 20. Or I can write 15, 20. If I divide by 5, it will be 3, it will be 4. Then this side will be 4 square minus 3 square, 2.65. This will be 2.65. So in this problem, there will be so many rounding errors, but that is okay. Okay, so once I find this, now I can use this joint to find P and TCD. So I will erase this portion. Okay, in this joint again I have two unknown, TCD and P, two unknowns. So what I will do, I cannot find anyone directly. So I will apply summation of f x first, I will get a relationship, then I will apply summation of fy, get another relationship, then solve it. So if I apply summation of fx, what I will get? I will get tcd divided by hypotenuse times my corresponding side 3, and then minus, oh, easy, good thing. I have two unknown, but one is vertical and one is inclined. So I can easily solve one using any one equation. Okay, so TCD then minus 8.37 divided by hypotenuse times my corresponding side equals 0. Then if I solve it, I'll get TCD directly. So 8.37 times 9 divided by 10 times 4 divided by 3. I got exactly 10 point something, but 10. Okay, so I got 10. Now I can find P. How? Summation of Fy is 0. Say upward is positive. So 8.37 is upward divided by hypotenuse. Hypotenuse is 10. Vertical side is 4.36. Hopefully, see, last time I used 9, this time I am using 4.36. When to use what? If I am taking summation of Fy. So divided by hypotenuse times my corresponding side. Corresponding side here now 4.36 vertical side. That time it was horizontal. So horizontal, this one, vertical, this one. So one is done. Then TCD. TCD we got 10 divided by hypotenuse times my corresponding side, 2.65. Got it? Minus P. P is minus equals 0. Now if I solve it, I will get the value of P. 8.37 divided by 4.36 divided by 10 plus 10, 2.65. If my calculation is right, P comes 3.27. So yes, I found force here, force here, force here, for this force. Anything else, I found the slope, because slope is mostly given. So I do not need to find slope. Sometimes they will not give you slope, they will give you the force. So in this way, the problem might play with you. But as long as you know the concept, it's very easy. You can take any joint, or you can take any section, and then find it. Now, so what is my force BC? So let us check. Let us check one value. Okay, so okay, I will delete here. So here what I did, I used all the joints. Now if I take a section here, where, say if I take this section, okay, first make it clean. If I take, say, section here, cut here, this is TBC, the slope here is 9, that was is 10, this portion was, okay, write it down, 9, 10, this was 4.36, this side. If I take this section, if I take this section and take moment here, summation of moment at A is 0. Okay, say clockwise moment is positive. My first force is 2, keep distance is 8 feet. This TBC has two components, one is horizontal, one is vertical. Say this component and this component. First this one. So TBC divided by hypotenuse times my corresponding side is 9 horizontal. What is this distance? Do I know this distance? Yes, because if this is 10, if this is 10, that means then this will be 6. Yes, so if I take this triangle, The slope of this triangle is 3, 4, 5. So if the length is 10, this will be 8, this will be 6. That means I'm multiplying by 2, 10, 2, 6, 2, 8. That means this distance is 6. So this will be 6 feet. Other component is vertical component. Okay, did I use the right sign? If I take moment here, clockwise positive, the 2 will give me clockwise. This component will give me counterclockwise moment, negative. This again, this component will give me clockwise moment. So TBC 4.36 times this distance. This distance is now 8 feet equals 0. Okay, it looks very big calculation. So 16, keep it here. What is the, so 9 times 6 divided by 10. So 5.4 here. What about here? 4.36 times 8 divided by 10. So I got here 3.488 TBC equals 0. Then if I solve it, 1.912 TBC equals 16 keep. So 16 divided by answer, I got TBC is 8.368. So 8.36 keep. Okay, so we got T equal 8.36 using another method. This time I took a section. Now you can match this answer with the previous finding. Actually, I forgot how much I got for this cable, but it should be same. Check your video. If it is same, then that means our analysis is correct. If it is not same, something wrong, we have to go back and check our calculation. Conceptually the problem is right, calculation mistake, but I think there is no calculation mistake. I can remember the answer here or something like that, or it should be very close. It may not match exactly because of so many rounding error. Say here some rounding error, here some rounding error. So that is not a problem. So hopefully you understood the cable with segmental load. What to do? Take a joint or take a section and apply equilibrium equation, find one by one. In different sometimes they will give you load and ask you what is the slope, what or the tension. Sometimes they will give you load and slope and ask you what is the force. Sometimes they will give you force, then ask you what is the slope. So different way they can play. So you should not be scared. It's just all about take a joint or section and apply equilibrium equation. That's it. And never you will get negative answer, because cable cannot take comprehension. If you get a negative answer, that means something wrong in your calculation. Go back and check. Thank you. In next video I will discuss something else. See you then.